everyone! Today in this video we will see the detailed explanation about the data structure and algorithms. The name of the data structure is indicated by how the data is organized in memory. There are numerous methods for organizing data in the memory. The data structure is not any programming languages like C, C++, Java, etc. It is a set of algorithms that we can use in any programming language to structure the data in the memory. Okay, next we will discuss about the need of data structure. The structure of data and the synthesis of the algorithm are related to each other. Data presentation must be easy to understand so the developer as well as the user can make an efficient implementation of the operation. Data structures provides an easy way of organizing, retrieving, managing and storing data. Here is a list of the needs for data. Number 1. Data structure modification is easy. And number 2, it requires less time. And number 3, save storage memory space. And number 4, data representation is easy. And number 5, easy access to the large database. Moving on to the classification of data structure. Data structure is of two types, linear and non-linear. In linear data structure in which data elements are arranged sequentially or linearly, where each element is attached to its previous and next adjacent element is called a linear data structure. Some examples of linear data structures are array, stack, queue, linked list, etc. Unlike linear data structure, elements in nonlinear data structures are not in any sequence. Instead, they are arranged in a hierarchical manner where one element will be connected to one or more elements. In a nonlinear data structure, we can't reverse all the elements in a single run only. Some examples of nonlinear data structures are trees and graphs. Next, Lakshmi will explain to you about the linked list and all the data structures, algorithms and codings.
Hi guys, I'm Lakshmi. So in this session, we are going to discuss about the linked list. So linked list. So linked list in the sense it is similar to the array. The only difference is the memory allocations. Let's say in the arrays, first it is, let's say it's stored in the location of 1000. So the element, let's say it's 10. Okay, so the next element will be stored in the 1004. The element is 12 because integer takes 4 bytes of memory. Okay, so and the next element will be stored in 1008 and next will be of 1012, like this it goes on. But in case of linked list, it will be containing two things. One is a data and the next one is the node. Okay, so more precisely, linked list will not be stored in a contiguous memory. Okay, not continuous. Okay, so in case of array, it is stored in the continuous memory. So here we are using the next node to store the which is linking to the next element. Okay, so this is how the node looks like. Yes, so this is the node. So it contains two parts. One is data and the other one is the linking part. That is the address to the next one. Okay, so here the next data, it will be pointing towards the next element. It goes on. So the last element will be pointing towards the null. Okay, so first whenever we say a node, it will contain the data. Let's say the data is of 26. Okay, so the 26 will be here and this will be pointing towards the null. Okay, so this will be pointing towards null. That's it. Okay, so when this is the first element, this will happen. Let's say I'm storing the next value. Okay, in that case what happens is, let's say this is the other node and I'm storing 10 to it. Okay, so this 10 will be pointing towards the null. So now I have to join these two. So what happens in that case? We have to draw a reference here. Okay, this 26 will be pointing towards this 10. Okay, so now previously this is the head and tail as both. Okay, so now what happens? This becomes the tail and this is no any longer a tail. This is only the head and this link is also deleted. Now let's say I have to insert the new element. So what happens? First we have to draw a node. And let's say this element is of 12. Okay, and 12 and this will be initially pointing towards the null. Okay, so now we have to join it. At the end in the sense, we have to traverse through the whole list. There is 26, it is pointing towards 10 and 10 is pointing towards the 12. So 10 is initially pointing towards null. So we have to link it here. So then we have to delete this reference and this is how the node looks like. Then what we have to do? We have to change this tail part. Now this should be the tail and the head is not changing. This is in case of a insertion at the end. Okay, in case of beginning in the sense, what happens? First we have to create a node. Let's say the node is 9, data is 9, and its next will be initially pointing towards null. Okay, so now the heads before should be this new node. Okay, so we have to create a reference here, and this will point towards this, and this null has to be deleted, and then we have to change the head also. So now the head element should be this 9. Okay, so this is how it goes. So in case I have to insert the new node, so before this 9 we have to insert that element, and that should be shifted to the head. Okay, so insertion can be done in 3 ways. No, not only 3, like it can be inserted at the head or at the tail or in the between also. Let's say after 26 I have to insert, that can be done. Before 12, that is also possible. Okay, so these are the ways of insertion. So now let's move to the coding part. So first thing is I have to create a node. Okay, so we can give it as a create node. Okay, let's mark it as a heading. So here we are using a Python language for implementing it. Okay, so here first we have to create a class with the name node. Okay, so then we are giving the constructor, so def underscore underscore and nut underscore underscore of. So as usual, first parameter is self and the next is of data. Okay, so this is the element to be inserted. Let's say I have to insert 26, so that has to be present here. Okay, so next we have to give a self dot data equal to the data, and then self dot next should be point towards null. So initially we have created a node here with the null pointer, right? Let's say this is the node. So we have inserted the 6 or something. Then its next will be pointing towards the null. So the similar way has to be done. Okay, so this part is done here. So this is a way of creating the class. Class node. That is creating the node. Okay, so then we can do insertion, right? So let's give it an insert at the beginning. So insert at begin in the sense we have to insert the elements in the head element. So the head element will be keep on changing, but tail will be the same. Okay, so first what we have to do for the insertion at beginning, let's say there is no element, that is 6 is the only element. So we have to mark that new node to be the head itself. This is first case. Otherwise what we have to do, we have to check with the we have to take the new node, its next should point towards the head element. Okay, new node is created, its next should point towards the head element, and then what we have to do, this head element should be shifted here. Now this 6 is the head element, this is no longer a head, and this null will also be deleted. So this is how we'll do the insertion at the beginning. Let's give it as def push off. Okay, here we are passing the self and then the new data, new underscore data. So using this data, we have to create a node at first. Okay, let's name it as new node. So new node is equal to node class is called with this new data. Okay, so as of now, a new node is created. That is like 6 node is created. Next, what we have to do, new nodes next should point towards the head element. Okay, so we have to give it as new underscore nodes next is equal to the head element, that is self dot head. Okay, then what we have to do is, the head element is new node, right? So we have to refer that. So self dot head is equal to new underscore node. Okay, so this is the way of inserting an element at the beginning. So now let's move with the next insertion, that is insert at the end. Okay, let's comment this as well. Okay, so insertion at the end in the sense what happens, let's say after 12 I have to insert it. So in this case what we'll do is we have to create a new node. So this creation of new node will happen in all the cases. Wherever you are inserting it, this will be common. Okay, so let's create an element with 90, that is 90. Okay, so what will happen, its data is inserted, its next will be pointing towards the null. Okay, so next what I have to do, we have to check with the head element. whether its next is null. Its next is null? No, it is pointing towards 9. So what we have to do? We have to check with its next. 9's next is 26. Not null. Again we have to do the traversal. So 26 next is 10. So 10 is not null. So 10's next is 12, not null. But 12's next is null. So in this case what we have to do? We have to mark this. That is, the present node's next has to be the new node. So automatically its reference will be removed. So similarly we can make the tail also. So this will be taken as the tail. Okay. So this is the way to insert at the end. Okay. So first we have to check whether there is no element. If there is no element, then the new node will be the head and tail both. Okay. Otherwise we have to do this traversal. Okay. Let's see how we implement in the program. Okay. So def, let's say I'm giving us append function. Append is the function name, self comma data. That is new underscore data. So what we have to do then? First we have to create a new node. So new underscore node is equal to node of the new data will be taken. New underscore data. So next what I have to do? I have to check if the self dot head is null. Head is equal to null or head is null. Both are same. Okay. If it is none in the sense, then new node will be the head element. So we have to refer as head is equal to the new underscore node. And then we have to stop this process. Else we have to take a temp node. So temp is equal to the head element. So why we are using this temp in the sense? So let's say I'm using the reference of head itself. So head will be moved here. Then head will be moved to 26. Then head will be moved to 10. Then head will be moved to 12. So in that case what happens? Let's say I have to insert the element, let's say 67. So I have created the node with the element 67. And this 67 has to be inserted before the head, which means it has to be inserted before 6. But if we traverse using head, it will be inserted before 12. That should not happen. So that's why here we are using some temporary node. So temp is equal to self dot head. Then we have to traverse it until we reach the end element. So for traversal, for the iteration purpose, we are using this looping statement. Okay. So we can give us temp's next is not null. Okay. Temp next is not null. So if it is not null in the sense, we have to continue with the traversal. So temp is equal to temp's next. So let's say at some point, that is after 90, what will happen? Its next is null. In that case, its next has to be that is the new node, right? So we have to do that process. So once the loop ends, temp's next has to be the new node. Okay, and then if what will happen, that will be the tail also. So if I'm referring the tail in the sense, we have to give us self dot tail is equal to the new node. So new underscore node. And similarly here also we can give, that is the first element, that is the tail as well. So self dot tail is equal to new underscore node. Okay. So this is how happens in the insertion at the end. Okay. So next is insert after a key. Okay. So I'm giving the topic as insert after a key. Let's comment this as well. Okay, so in this case what happens is, let's say after 10 I have to insert 67. So what will we do? It's not in any contiguous address or something. So what we have to do is, we have to do the traversal from the first. We have to check whether 6 is equal to 10. No. Then 9 is equal to 10. No. 26 is equal to 10. No. 10 is equal to 10. Yes, it is. So in this case, we have to do the linking part. That is, let's say I'm taking the temp. Okay, let's say this is the temp. I'm giving as TE. So TE's next should be the new node. And new node's next should be the temp's next. Okay, and this linking part has to be deleted. Okay, so previously what we can do is, we can take this temp and this X to be of temp's next. Okay, then we can do the linking process easily. That is, temp's next will be new node and new node's next will be X. That's it. Okay, let's do it here. I'm giving us def insert after key. Okay, so here we have to give three parameters. One is self and next one is the data to be inserted. Let's give it as new data itself, new underscore data, and next has to be the key value. Okay, so now what we have to do is we have to create a new node, that is default. So new underscore node is equal to the node of this data, new data. Okay, so next what I have to do, we have to take the temp is equal to head element. So self dot head. So next we have to check. First we'll check with the head element. Okay, if of self dot head is equal to the key. Sorry, self dot heads data. If that is equal to key in the sense, we have to insert after the head. Okay, so otherwise we have to do the traversal part. Okay, either you can give this itself in the looping, otherwise you can give it separately also. So here what I'm going to give us using the looping. So we can give us while of temps data. Okay, that is the nodes data. That should not be equal to key. If it is not equal, so here 6 is checked with 10, not equal. So what we did, we have automatically moved to the next element, that is 9. So here also we have to do the same. So temp is equal to temps next. If it is equal in the sense, so there we stopped and we have taken the, its next node is also taken. Okay, so here we are checking that if the temps next is null or not. Because let's say after 90, I have to insert this 67. So there is no element, right? In that case, this will be the tail element and there is no linking part has to be done. Okay, so if it is null in the sense, we have to just give it as temps next to be the new node, new underscore node, and the tail will be this one. That is self dot tail is equal to this new node, new underscore node. Otherwise, in the else part, what we have to do, we have to take that x is equal to temps next. That is, this 12 is taken as x. Then what we have to do, we have to give the temps next to be the new node and new nodes next to be this x value. Okay, so temps next to be the new node. So the one linking is done. That is this linking part is over. So still we have to do this linking part. Okay, that is new nodes next has to be equal to this x value. So by this way, this linking will also be done. That's it. Okay, so this is how we have to insert after a key. So after this we can stop. Okay, so similarly we can insert before a key also. Let's say example here, I'm having 67. So before 67, I need to insert the value. Let's give it as 91. Okay, so this 91 has to be inserted before this 67. So what we have to do, initial stage, we have to create a node, then we have to check like the same traversal. But what happens in this case is we cannot be able to travel back because it's a singly linked list. Singly linked list, the traversal can be done in only one way. That is 67 will refer to 12. We cannot refer back 12 to 67. Okay, so what we can do in the better cases, first we can check it with the head element. If not, we have to check it with its next 9, not equal. Then we have to move here and we have to check with its next value. Let's say I'm taking this as the M value, M node, or let's say this is the T temporary node. Okay, so this is not temporary, right? So we have to delete these steps. This is not T and this is not X now. Okay, so now what we have to do, we have to check with its next data. Temps next data is 26. Is it equal to 67? No. Then we have to shift here. The T is this one and this is not T anymore. Then T is next. 10 is equal to 67? No. So T has to be shifted here and this is not T anymore. Then here we have to check. T is next is 67. Is it equal to 67? Yes, it is. Then here we have to insert and we have to change the linking part. Okay, so let's move to the code also. So insert before a key. So let's comment this as well. Okay, so def insert underscore before key. Okay, so here also we need to give 3 parameters: self, and then new data, and then this key value. Okay, then we have to create a new node at first. So new underscore node is equal to node of the data, that is new data. Alright, so next what we have to do, we have to check it with the head element at first. So let's give it as temp is equal to head at first. So self dot head. Then we have to check if the self dot heads next, it's data, right? Its data is equal to the key value. If s in the sense, we have to make the value to be inserted. Let's say 91 before 6. So this has to be the head element, and its next should be the head itself. Okay, so what we have to do, this should be the new node should be head, and the previous head has to be the its next. Okay, so we can give us temp is already taken, right? So temps, okay, we have to give us the new node. So self dot head is equal to the new node. So let's say this is made as the head element. So what we have to do, we have to create a linking part here. Okay, that is we have to take this is temp, right? So temp on head of save. So heads next has to be the temp. Okay, which means this has to be pointed, not this one. So I have to delete this also. Yeah, so this has to be pointed towards that element. Okay, so what happens in this case, now this is the head element, its next is pointing towards the previous head. Okay, so we have to give it as temp, that is new nodes, next has to be the temp. Okay, alright. So if not, which means the head element is not matched in this sense, what we have to do, again we have to do the traversal. Okay, so let's take an example as 12 is already there. Let's take as 14. Okay, so we have to say that before 67 I have to insert 14. So 91 is checked with 67, no. So it will come to this else part. So in the else part we are checking with 6. So 6, that is temp's next data, right? So 6 is equal to 67, no. Then it's next, 9 is checked, like that. So we are not, in the previous insertion after a key, we have checked with the same data. But here we are going to check it with its next data. Okay, so while of temp's next data, which means if I am pointing this as the temp, its next data is 6. Is it equal to 67? No. Then temp will be shifted here. Then its next data is checked. It goes on in this way. Okay. So actually the braces has to be here. Alright. So now what we have to do is we have to check whether that is not equal to key in the sense we can do the traversal. That is temp is equal to temp's next. Okay. So once that is reached, let's say I have reached the 10, 10's next is 67. So what we have to do, we have to take this as the x and let it be as temp itself. Okay, now temp's next has to be the new node. Okay, and new node's next has to be the this x value. Then this link will be deleted automatically. Okay, so we have to do this process now. So let's give it as x is equal to temp's next. Oops. So temp's next, and then temp's next is equal to the new node that is created, and then we have to give the new nodes next to be this x itself. Okay, and then we have to stop the process. That's it. So this is a way of inserting a key, inserting the value before a key. So as of now, we have discussed how to create a node and insertion in various places. That is at beginning, at end, after and before a given key. Then at last we can discuss the deletion part. That is delete a key. Okay, so delete a key in the sense we have to delete that particular key. Okay, so we'll just comment this at first. Alright. So now let's say I have to delete this 6. Okay, so what I have to do, this let's say head is the starting element. So heads next has to be the deleted elements next. This has to be done. So what if the head element has to be deleted? If the head element has to be deleted, this has to be shifted as the head and this has to be deleted. Okay. So first thing is I'm giving us def delete of, here we have to pass only two parameters. One is self and the next is key. So here no need of creating any notes or something. So let's give it as temp, which is equal to the head element. And we have to check if the head's data. So self dot head dot data. So here we are just checking with the data. So self dot head is equal to the key we are checking. If S in the sense, what we have to do? We have to delete it. So here what we did? So this next element should be the head element, right? Let's say head. Its next should be the head now because we are deleting 91. So automatically this 6 becomes the head element. So the whole link will be deleted and the space allocated will also be deleted. So for deleting the space allocated, we have to give the word del. Okay. So we have to give it as head element has to be changed. So self dot head is equal to the heads next, which is the temps next we can give. Okay. And then we can give us del the head element. So self dot head, sorry, the temp will be deleted because head is now it's assigned to the different element. So we cannot delete the head element, we can delete temp and then we are stopping the process. Otherwise, what we have to do, already the head value is assigned to temp. We are checking with the head element. Let's say I have to delete 67. So 6 is checked with 67. No. And what we'll do, otherwise you can do one more thing. Instead of checking with its data, you can check it with its next data. Because we have to create a link also, right? So let's say 6 is checked already. It's not satisfying. So its next data is 9. 9 is checked with 67. Is it equal to 67? No. So what we have to do, 9 has to be moved, like the temp has to be moved to the 9 and we'll check with the 26. So 9's next is 26. It is checked with 67. Is it equal? No. So again we have to do the traversal. So this becomes the temp, that is TE. Then this will not be TE anymore. So it will check. It's next. 26 next is 10. Is it equal to 67? No. Then what we have to do? We have to shift this to TL, temp. Okay. So I'll change this to temp. Then temp's next is this one. 10's next is 14. Is it equal to 67? No. So still we can do the traversal. So this becomes this TE. And this has to be deleted. Then it will check whether 14's next is 67. Is it equal to 67? Yes, it is. Then as usual, we have to change this to X and we have to change the connections. So this has to be deleted and the connection has to be made from temp to the X next. Temps next. Okay. So by this way, we are deleting it. Okay. Now let's move to the coding part. In the else, I'm giving us first while loop. So while of temps next data is equal to the, not equal to the key. If that is the case, we can shift. So temp is equal to temps next. So it will be traveling. At some point it will stop. Let's say at X. So X is equal to temps next. Okay, that's 67. Okay, so next what I have to do, we can take a other variable also. That is temps next is equal to the X next. Okay, either you can take it as this, otherwise you can take in some variable also. Because that has to be shifted. Okay, so what we are doing is, let's say that is the X, the temp next is, which means the 67 is the, or let's take the same 67 again. Alright. I'll just delete this connection and we can create that 67 again. So what happens in this case, 67 is pointing towards its X value, right? That is 12. And this 14 is pointing towards 67. So what happens in this case, it's next, this is pointed as X. And this has to be changed as temps next. So temps next has to be this 67. So this link will be deleted automatically. Okay, so no need of taking this as X. If you think it's confusing, you can take it as Y is equal to next X next, and then you can connect as temps next as Y also. Okay, so let's try in both the ways. So as of now, temps next is this 12. Okay, that temps next is x next. And then we can delete the x. So this is one way. And the other method is, let's give it as other way. Okay, so other way is I have to take it as x is equal to temps next and y is equal to x next. Then temps next has to be this y. Okay, so this is the other way of doing it. Okay, let's comment this as well. Okay, so this is the way of deleting it. So at last, how to print the elements? That is, we have to traverse through the linked list. Okay, so let's comment this also. So for traversal, what we have to do is we have to take with its next only. Until the text is not null, we have to shift. So let me give it as def printing the list of self. Okay, so what we have to do as usual, temp is equal to self dot head, then while of temp. The temp should not be equal to null. If that is the case, we have to print the temp's data, which means this is the temp, its data is 6. That has to be printed at first. Then it shift to 9. That data has to be printed. Then it is next is 26. Is it equal to null? No. So 26 has to be printed. Its next is not null. So 10 will be printed. It goes on in this way. Okay. So print of temps data. Okay. Comma end is equal to some space. Alright. So and then we have to travel, right? So temp is equal to temps next. Okay, while of temp, print temp dot data and then temp is equal to temps next. That's it. It will be keep on traveling and then we can stop the process. So this is the way to print the elements. Okay, so now we can combine all these together in the single program. Okay, let's say if the case is 1. So let me give it as case 1 in the sense, let's say it is of insertion. Okay, I'm giving us insert at beginning. Okay, and in case of case 2 in the sense, I have to insert at end. Okay, so it is of insert at end. Okay, and in case of case 3 in the sense, insert after a key. And in case of case 4, which means when the user types is 4 in the sense, I have to do the insert after a key, before a key. Okay, let's give that here. Insert before a key. Okay, and next has to be case 5, which means it is of deletion. And at last, case 6 in the sense, let's change this also to uppercase. So case 6 in the sense, we have to print all the statements. Okay, so let's comment this at first. Alright, so now let's combine all this together in a program. Okay, so first what we have to do is we have to get the input. So n is equal to int of input of. So next what has to be done? We have to check through this number. If of n is, or let's check that it's given in the looping. So while of true. Okay, let's give it as while of true. Because until we find it as 6, sorry, or let's say we can add one more case also. Let's say case 7. If the 7 is entered in the sense, we have to stop all the process. Okay, which means exiting process. So while of true, we are getting the n value. So n is equal to int of input of. And we have to check. If the n is equal to 1 in the sense, we have to insert at the beginning. Okay, so here we have to give it as, we can call this insert at beginning function, right? So insert at begin, or what is the function name we have given as push, it seems. Yes, it's a call push. So we can just call the push function. So push of, here we have to push it with the element, right? So within this itself we can get the element, or let's get the element separately. So x is equal to int of input of. So x is the data that has to be pushed at the end, pushed at the beginning. Yes. So next is end. For that we have given the function name as append. So elif n is equal to 2 in this sense, we have to get the same one element, that is x is equal to int of input of. Then we have to call the function append of this x. Okay, then what if it is of 3? If it is of 3 and 4, we have to get 2 elements. One is the data and the next one is key. So for after, we have given data and key, data and key. So we have to mention that order also. Okay, let's get two values x and y, which is equal to map of in comma input of dot split of method. Okay, so here we have to give it as the function name is insert after key. So insert after key of, we have to pass two parameters x and y. Let's say x is the data and y is the key value. And if n is equal to 4 in the sense, we have to get to x comma y is equal to map of in comma input of dot split of method. Okay, so next is we have to call that insert before. So insert underscore before underscore key of x and y's. So what if it is of deletion? For if the n is equal to 5 in the sense, we have to delete it. So there we have to get only one input for deletion. So int of input of. Then here we have to call that function. So the function name is given as deletion. Let's change it to deletion. Okay, so we have to call this function here, that is deletion of this x value. So if it is of print, no need to get any input. We can just call the printing function. So the name is print underscore list. So print underscore list of. Okay, elif, that is if the n is equal to 7 in the sense, we have to break the whole loop itself. Okay, because while of true in the sense, it will be running into the infinite loop. So to avoid it, I'm using this break. Okay, that has to be used for mandatory. So here I'm using it for this 7. Okay, one thing. And next thing is, first we have to create a class for this whole, because let's say object for this whole class. Let's say all these things are given in the whole class in the sense, we have to create a instance for that class. Okay, so let's do one thing. Let's copy all the processes inside it. That is from the creation of the node. Okay, so let's say create node. I'm just copying it. Okay, and next is of insertion at the beginning. So let's copy this also here. Okay, so before this, what I'm trying to do is, let's create a one more class, naming as singly linked list. Singly linked list. Okay, so let's give it as S as the uppercase. Okay, so here we can give the head and tail to be of none initially. Okay, that can be given inside the constructor. So def underscore underscore init underscore underscore of self alone. Okay, so here we are giving us self dot head is equal to none. Similarly, self dot tail also equal to none. Okay, because later we are changing it. So we can give this pushed inside this class. And next is append function. Let's copy this append. Okay, so this is insertion at the end. Okay, so this is done. So next we have to take this insert after a key. Let's copy it. So let's paste it here as insert after a key. So for the clarification purpose, we can mention this also. Okay. Yes, I guess all the things has to be inside. Okay, right. So next, here we can mention it as insertion after a key. Okay, and similarly here also we can give us insert at end. Okay. So here I am mentioning it as insert at end. Similarly here also we can mention as insert at beginning. Okay, so next is after a key. So here we have to paste our code. So all these has to be inside this block. So next is of insertion after a key. So insert after a key. Sorry, after a key is done. Now it has to be of before a key. Okay, so here we have to copy this code. And all these things has to be within the block. Done. So next has to be the deletion part. So we can mention here as the deletion. Okay, then let's copy that code. Yes, let's give this code here. This is the code for deletion. So all these things has to be within the code block. So let's move one tab inside. And this is not needed because both are same. And at last we have to print it. So let's give us printing. Okay, and we have to copy this printing code. And let's paste it here. Similarly, this has to be within the code block. Alright, so now all the codes are done. So it will go and call this function. So first we have to create this instance, right? Let me give it as SLL, which is equal to, this is created for the singly linked list. So we can give it as singly linked list. Okay, so next we have to give it here, right? So next we have to call this function, and all these methods are within this singly linked list. So we can give it as SLL dot. That is, we are calling the function using the object. So SLL dot append, SLL dot insert after, then SLL dot insert before, then SLL dot deletion, then for printing SLL dot print list. That's it. Okay, so let's execute it now. So let's give it as 1 at first, which means insert at beginning. So I have to insert 3. So 3 will be inserted. Let's try printing it using 6. Okay, it shows only 3 is inserted. Let's say I'm giving 1 again and I'm inserting the value as 4. Let's give 6. So 4 and 3. Because 1 in the sense insert at beginning. Let's give it as 2. This has to insert at the end. Let's give it as 5. So now let's try printing it. So 4, 3 and 5. Because 4 is the first, next 3 and next is of 5. Okay, and let's give it as 3. So 3 in the sense it's insert after a key. So here we have to give 2 elements. Okay, let's say after, first is the data, right? Yeah, first is data. Let's say I have to insert 7. That has to be insert after 3. Okay, let's try printing it. Yes, so after 3, 7 is inserted. Let's give 4 for this. So 4 in the sense insert before. So before 5, I have to insert 12. So 12 comma 5. Let's try printing it using 6. So 4, 3, 7, 12 and 5. Okay. So for printing is also checked, and all the things, insertion at begin, end, before and after a key is also checked. Let's give 5. So 5 in the sense we have to delete an element, right? Let's say I'm deleting 12. Let's try printing this 6. Okay, so now the 12 is deleted and the remaining values 4, 3, 7, 5 is get. So this will keep on going until we enter 7. Okay, let me enter 7. So it is stopped. Okay, so this is the whole code for the singly linked list, guys. Thank you.